So everyone can hear me, yeah? So I'm going to talk about zero friction performance instrumentation and monitoring. This is about a project that we've recently finished at OutSystems. So I'll go through it. So the agenda, I'm going to give you some context so that you understand the project. I'm going to talk about what is the OutSystems Platform, and then I'll go through the whole project lifecycle from the inception to its conclusion. So what is the OutSystems Platform? It's a product that we sell. It's the only product that we sell. And it allows you to create, deploy, and change custom hybrid mobile apps and web applications really, really easy. At least that's what we think it does. And it's a bit like Visual Studio and Eclipse for Java, if you know those languages. The difference is that we do it all visually. So this is Service Studio, it's our IDE, and it's all visual. You don't have to write almost no textual code. This is code, but this is visual. So this is like an action or a method, and you have a workflow. First, you are executing a DB query, then we are making a REST call, in this case to Facebook, and then we do just a plain variable assignment. And we generate a model from this. Then when you want to publish this to an environment, be it development or production, you just push a button, we generate the application code, we push it to a web server and to a database, so we generate all the DML code so that you can upgrade the DB schemas. And then we also have some tools around operations, monitoring, security, and that's where I'm going to focus on. So at the start of this project, we needed to find what was the problem that we really wanted to solve, because there are always lots and lots of different problems, and we have to focus on one. And to find out this problem that we want to solve, we have to think about our clients, the people who has a stake in our product. And in our case, and probably in many of your cases, the people who really are using your software are not your only clients. In our case, developers are obviously one of our stakeholders. Operations guys are one of our stakeholders, but there are many different ones. So we have to listen to all of them. We have to listen about CTOs and CEOs because they are the ones who pay for the product, so they have to like it. We have to think about the architects because we are introducing a new kind of architecture, so the architects have a say on this. We have to think about the guys from security, the ops guys, the geeky developers, and also the casual developers, because one of the main goals of our platform is to lower the barrier to entry for people who want to build web or mobile applications. And how do we reach them? We do some interviews with them whenever possible. We use our sales team to understand what are the problems that they are facing selling the product. We talk with our services team. We check some industry analysts, Gartner, Forrester, because they are very influential in our ecosystem. And we do some competitor analysis to see if we are ahead of the game or not. And when we do all this talk, we get a lot of data, we hear a lot of those problems, and we have to focus on one problem where we can make a difference. Because we can solve lots of different problems, as you can solve a lot of different problems, but we have to focus on one where we can make a difference. And after doing all this field research, we define an ultimate goal. All of our projects have an ultimate goal. All our teams actually also have an ultimate goal, and these are a crucial tool to keep everyone on the same page, to ensure that every activity, every task in our project serves the purpose of achieving this goal. And in this project, the goal was to reduce to zero. It's always very ambitious. Reduce to zero the time taken to identify performance issues and also pinpoint their source or their cause. So the first takeaway in all of your projects is to define your own ultimate goal. It's really a very nice tool. Once we have this ultimate goal, we start to break it down into use cases. And for this project, we've decided that we were going to tackle performance issues to help performance troubleshooting. At the start of the project, we had other options. We also thought about users adoption and that stuff, but we decided to focus on performance. And performance is really a huge topic. There are many, many things that can affect performance. So again, we really need to focus. And you have to think about our product as you should think about yours. And so OutSystems Platform enables developers to build web and hybrid mobile applications. So we are talking about distributed systems. This is a typical web application, very simple. We have the user that is using his laptop or her smartphone, her tablet, and it's accessing our web application. And this application can then make some calls to databases, to service calls, REST, SOAP, whatever you do. And in our case, we also have one thing that we call sheaf, or extensions, for those cases when you cannot code in our language. You have to go to C# or Java. And we don't have any kind of control or knowledge about that custom code. So that's also relevant for us. And so the performance bottlenecks for the kind of applications that are built with our platform are the usual suspects. Especially on mobile, if you are using a 3G or GPRS network, it can be really bad, so you have to be aware of that. And if your application is going to the database or to other services, it's really important to know if they are causing problems. Okay? Especially in services, it's useful not only for technical troubleshooting, but usually those services are not built by your own team, so you have to think who is responsible for solving the issue. So we decide to focus on measuring these things. So slow networks, try to identify slow networks, especially on mobile nowadays. Slow queries, slow integration calls or service calls, as you want. In our case, slow extension calls. And we also wanted to help identify this anti-pattern, the select n+1 problem that you've probably heard of. It happens when you have a remote call, be it a query or a service or whatever. And the query might be fast, but if you are calling it dozens or hundreds of times, it can make the whole request really slow. And this is an insidious problem because it's difficult to pinpoint it. When you have all these performance data, you have to be aware that just raw performance is meaningless. What does it mean to have a CPU consumption of 80%? Is that really a problem? Or if we have a service call that takes 10 seconds to execute, is that really a problem? Just with this information, it's not possible to know that. So we have to have a lot more context. For instance, if the user is accessing a login page, well, you want that login to be fast. If the user is just doing a weekly report and it's just one person that has to do it weekly, well, if it's slow, that's not too bad. It's to be expected. So user perceived performance in context is what really matters. It's not just raw data. We have to have this context, this user context. This is our case, and for the type of applications that we build, if you are doing web applications or distributed systems, probably you also you want to focus on these issues, but you know your product best. If you're building a rich application, like in our case our IDE, well, the performance profiles are completely different. So you have to find your own common performance bottlenecks. And whatever they are, you have to always present them, at least that's what we believe in, you always have to present them in a user-centered focus, because your software only exists for your users. So raw data is meaningless. How did we build the solution? And we have always this goal of making everything as smooth and seamless as possible. In our case, this is pretty simple. the developers use a visual model, so we just instrument the code that we generate. But you're probably not using a visual language, so you have to use different solutions. I'll give just a couple of examples. There are many different techniques. One of those is to proxy some key objects. Usually you have some key objects that are responsible for making these remote calls, for instance. In this example, and we're actually using this library, Boomerang is a library that does real user monitoring. So if you're using it, he's accessing a website and he clicks on the button, Boomerang helps you to measure, sometimes using standard browser APIs, helps you to measure the time it takes from clicking a button until receiving the response and rendering the screen. Boomerang uses this technique, and it provides a plugin, the AutoXHR, and this plugin basically proxies the XML HTTP request in a completely transparent way so that the JavaScript developers can just code and use their favorite library to access the server, and this plugin takes care of measuring everything and just provide the data. There's a very nice presentation called Measuring the Performance of Single-Page Applications, who gives a lot of information about these techniques specifically for the client side. You can also define and enforce some coding guidelines. You can, and actually we do this for building some of our internal products. So we can define some standard data access libraries. We can reuse some, or we can build ourselves one. We can define some standard REST client libraries, and then we can check that they are being used everywhere by code reviews. If you're not doing code reviews, you should start now. There are many advantages to doing code reviews, and this is just one of them. And you can also leverage static analysis tools. There are several tools that can enable you to understand if certain coding patterns are being used or not. For instance, for .NET, you can use Endpoint that can really help in this kind of tasks. So whatever you do, and no matter if it's performance instrumentation or whatever, you have to make the right thing to do must be really simple, and the wrong thing to do must be really hard. It's, well, just like a river that follows the path of least resistance. You must ensure that path of least resistance is the right one. Once you understand your solution and you know that you have to instrument in your code, you have to fight the Heisenberg Principle, which basically says that if you are going to measure something, you're going to interfere with it. And instrumentation can generate a lot of data. It's really an intensive task, so you have to think about this stuff. You have several constraints. You don't want your instrumentation code to take 90% of the time of serving a request. That would be really bad. You have, if you're gathering a lot of data, you have to take into account the memory consumption so that you don't hit some threshold that you don't want to hit. And you really have to think carefully about storage needs, because you can generate humongous amounts of data and that can fill up disks really quickly, and you have to be aware. So before going live, we think that it's really important to establish some performance baselines. So without your instrumentation code, what is the performance profile of your application? How does it behave? And then afterwards, you add your instrumentation code and you compare and see, is this acceptable or not? You do this by performing load testing, performance testing, in the most realistic way that is possible. In our case, for instance, storage was a real headache because we wanted to gather a lot of data, and we were just growing and growing, and we had to make some optimizations to make this bearable. After going live, it's important to think about throttling capabilities. If something goes wrong for some reason, you have to be able to switch off monitoring, if possible, or you can also think about, do I really want to to log all queries executions, or do I want some threshold? For instance, only queries that take more than 100 milliseconds get logged. You also can think about time to live policies. So you're going to store a lot of raw data, or not. You can push it. In our case, we store that raw data. And we have to think, how long do we want to keep this data? 1 day, 1 week, 1 month? Do we want this to make it configurable? So when doing this kind of stuff, you have to be careful, and you don't want to let your instrumentation bring your application to a halt. It's really easy to do this, so you have to prepare. Around the results. So we are producing lots of data. We want to consume that data. And instrumentation can provide very, very rich data points. When you start thinking about all the metrics that we can get automatically and without effort, it's like a playground, and you have to think about it. So in our case, we store per request many data points. Some of those are the endpoint metadata, so we store the URL, obviously, and we link that URL to the web screens and to our actions, so that we can put all this information into context and into in a user-centered focus. We store the end-to-end request duration, we store the client duration, the time it takes on the browser, the network, the server side, we log slow calls. We store the network type when in mobile, so we want to know if it's a 4G or 3G, GPRS, whatever. And we also store the mobile device type. This information is really crucial for mobile, because if your users are mainly using, for instance, low-end hardware, smartphones, well, you know that they don't have a lot of processing power in the client, so you have to take that into account. If they are mainly using iPhone 6 or that stuff, well, they have a lot of processing power, and so you can transfer a bit more processing to the client. This is important not only for after going live, but when you are doing new applications, this information can really help. So in the beginning, we defined a few key use cases, but we gather a lot of data. So we have here maybe a trade-off. So how do we handle this? Well, we try to have the best of both worlds. Nowadays, with all the microservices craze, everything is an API, so we've also built an API that provides this raw data. And this API is exactly the same one that we use internally to build our dashboard. So we've built a dashboard, which combined with the automatic instrumentation provides the so-called zero friction monitoring. So just an example of data that you can also build. Probably you're not using OutSystems. Maybe you are already using Dynatrace or New Relic or Splunk or Elk or something, and you can build your own dashboards. You can use these as ideas for those dashboards. One of them is to give the end-to-end breakdown. So how much time is the request being spending on the client, on the network, or on the server? This is something that is really important, because if you know, for instance, that you are spending most of your time on the network, probably you have one or both of two things. One, maybe the network is really lousy, GPRS, or you are sending too much data over the wire. And if you see that, well, 50% is on the network, you know immediately where to focus on. If, for instance, it's on the server, we can break down also, and we can focus on the remote calls. How much time are you spending on queries? How much time are you spending on service calls? And usually, not always, but usually, this is how a healthy application looks like, because most of the time it is spent on the application. Usually, if you are spending most of your time on the database, it's a bad indicator. Not always, but usually. And we also show the specific queries that are too slow queries or search or whatever. In this case, everything is a query. And we have the name of the query, that get projects filter, and we also show where is this query being used, so that you can go immediately to that part of the code and solve your issues. So, key takeaways here. You have to focus on your key use cases. Maybe they are similar to ours, maybe they are not. You have to understand those key use cases and focus your probably scarce resources on solving those key use cases first. But you also want to keep your analytics options open. So once you start gathering metrics, it's really easy to add more. So add it and keep it. And once you know new use cases that you want to build, or if the first ones aren't really the ones who are solving your problems, you have some historic data to build those new use cases. And always provide APIs for everything. And this is the end of the talk. Feel free to reach out, and there's time for questions. So
yeah, we have time for questions. Any questions, comments? To João? Don't be shy. Okay, we have one.
Hi, thanks for the presentation. I have a question about gathering metrics of your software. I mean, how much of this you can do pre-production and how much of this works in real production? So do you do something in pre-production that actually divides the metrics into separate tests, or you rather do it in one go?
I'm not sure I understood the question. You gather metrics.
You mentioned that some of metrics gathering, like, for example, resource consumption, may generate additional resource consumption that you don't want to account. Do you do some tests pre-production to measure separately every single piece of resource consumption?
In our case, we build a product that is then installed maybe on premises, or we also have a cloud offering. And what we've done is we've done this load testing in pre-production, let's say, and we do that. They're in a controlled environment. We have this cloud offering, and we know the common infrastructure that our users are using. So we used the same infrastructure to perform this load testing. We also did some extensive beta testing in internal installations, because almost all web applications that we use are built with the platform. So we do some extensive beta testing with the final binaries to understand that the application is behaving as expected. Okay. And then if something goes wrong in production for some reason, we have those throttling capabilities to handle it.
So it's actually a mirror of production environment, and you do it in one go?
More than one go, because we iterate, but yes, basically that's
all of the resources that you consume with your application are measured in one go?
Yes.
At the same time, in parallel?
I'm not sure what you mean by resources. For instance, we measure CPU, memory consumption. Yeah. We use standard tools for that. We don't use anything specific, and we measure all that stuff. We do different tests. We try to understand what are the main usage profiles of the application, and we do several tests to understand if everything is okay.
Okay, thank you.